space pirate.
Why Jupiter should be called the liquid giant.
Jupiter, named after the king of Roman gods, is the fifth and largest planet in our solar system, and it has a radius of about 70,000 kilometers. Compare that with our home planet Earth, which is just about 6,400 kilometers. It is so large that 1,300 Earths will fit into it. It is the first of the so-called gas giants in the outer solar system. Its gravitational influence in the solar system is so significant that it tends to wobble the sun in its wake. In lots of aspects, Jupiter is like the sun. It is 95% hydrogen and helium. Jupiter is considered a gas giant by most astronomers because it is mostly composed of elements that are gaseous at Earth's average temperature of 25 degrees Celsius and pressure of 760 mm mercury. Judging by Earth's atmospheric conditions in which these elements are gases, it is easy to generously consider hydrogen, helium, or even oxygen to be gases. But how true is this? If you live elsewhere in our solar system, your reality might not be the same, because we all know that every element vaporizes or solidifies when subjected to favorable condition. If you live on a planet whose hottest temperature is 0 degrees Celsius, water will be one of your solid state mineral. So the question is, why is Jupiter and all the rest of the gas planets in the outer solar system considered to be gas giants? Why are planets not consisting of a terrestrial surface made of solid on which to land and explore considered gas planets? Let's take a journey to Jupiter, where we'll navigate through the whirling storms and freezing depths of a supposedly gas giant, with the possible aim of any landing surface in the planet. The time is now, and you are Clark Kent of Smallville, tired of winners and sinners of planet Earth, and have decided to take the next spaceship, Juno 2.0, to Jupiter in search of a new home. Approaching Jupiter and slowing down from a speed of 250,000 km per hour to just about 1,000 km per hour and even slower, your troposphere detecting device announces you will kiss Jupiter's troposphere in 9, 8, 7, 6. You look through the hatch. Lying ahead of you is a vast expanse of light brown cloud, whirling aimlessly in all directions. If you were in Earth's atmosphere, these gases wouldn't be visible at all. But out here, your conditions are different. The temperature is negative 150 degrees Celsius. And you already know that the Jupiter's troposphere is made of ammonia, sulfur, methane, and water vapor stretching down only about 50 kilometers. As you drip past layers of ammonium cloud into the planet's interior, with storms of unimaginable proportion, thunder striking and hurricanes cutting at each other, you decide to dive out of Juno 2.0 to use your superhuman skills to feel your new climatic condition. At about 220 kilometers, the pressure on your back rises beyond 100 times Earth's atmospheric pressure. The planetary substance, made of hydrogen and helium, becomes considerably dense and begins to wet your dress. Shortly, you begin to wonder if it's raining on you. You're beginning to adjust your mind because it feels you have dived deep into a translucent ocean, not of water, but of a superfluid-like liquid. Yet you have no memory of landing on any liquid surface because Jupiter has no surface at all. Hydrogen and helium have long passed their liquid point pressure, but have refused to turn into what your earthly friends call liquid, because the rise in temperature is way above their critical points. Yet this superfluid keeps tumbling like a giant washing machine. Now, you're way beyond 500 miles down the surface, and your senses are now modified by the hot dark superfluid-like liquid, becoming thicker than mercury, and the darkness is beginning to disappear from the continuous non-stop thunder-like sparks. At this point, it dawns on you that you can't send any message to Krypton nor to Earth to share your new experience because no civilization known to you has invented any means of radio communication that can penetrate this dense layer of liquid capable of absorbing any form of radio wave. At 5,000 kilometers, your surrounding temperature is over 3,500 degrees Celsius. That's a temperature that's half that of Sun's surface and capable of vaporizing pure iron. At 20,000 kilometers down the surface, you are at a zone where the pressure is more than 2 million times that of Earth's surface and your sense of differentiation between liquid and solid is impaired. Well, you can call it metallic hydrogen, but then it makes little or no sense at all. At this point, law of flotation begins to experiment on you and you can no longer go further. Your journey has ended without you achieving your goal. You are neither floating in a gaseous substance nor standing on a solid surface, and your immortal mind begins to wander. With this extreme temperature of galactic proportions, will it be possible for Jupiter to have a solid state metallic core beyond this metallic hydrogen? Why do the Earthlings insist on calling this planet a gas giant when it's been liquid most of the way, starting from less than 10,000 kilometers down the surface? If Earth, a rocky surfaced planet with gaseous atmosphere, is referred to as a rocky planet, why should Jupiter, a hot liquid volume with gaseous atmosphere, be called a gas giant? Let's call it a liquid giant.
You can watch our next episode to hear us argue how planet Mars contributes to Earth's global warming. Kindly subscribe. Don't forget to like and share. See you next time.